Hello everyone, this is a solving quadratic equations by completing a square video, and just a couple of remarks before I start showing you how this method of solving quadratic equations. Remember, the quadratic equation is the equation that has a variable with the power of 2 in it, and simply getting it by itself is most of the time not an option. So far I have shown you how to solve quadratic equations using factoring, and that's applicable to equations where a trinomial or a binomial or any sort of polynomial on one side of the equal sign is factorable. An example of such is x squared plus 2x plus 1 equals 0. This, notice, is a quadratic equation because it contains x squared in it, or any variable that for that matter squared, and it's a 0 on the other side. If it's not, you need to make it a 0 by moving things to the other side of the equal sign. But this trinomial here on the left is factorable. All you need to do is find two numbers that multiply to 1 and at the same time add to 2. Those numbers are 1 and 1. 1 times 1 is 1, and 1 plus 1 is 2. There's 2 right here. So knowing that, you can write this trinomial on the left side as x plus 1 times x plus 1 equals 0. To solve this, you simply take each of the factors, which they happen to be identical here, x plus 1 and another x plus 1, and make each equal to a 0. So x plus 1 equals 0, and you don't have to write it twice. But if this was different, then you would. And that means x equals -1. And this is how we normally would solve quadratic equations. However, what if I change this equation, and instead of x squared plus 2x plus 1 equals 0, I say x squared plus 2x plus 5 equals 0. So let's say hypothetically this was a 5. In this case, following the same technique, you would have to say what two numbers multiply to 5 and at the same time add to 2. Well, what multiplies to 5? We really don't have that many options. 5 times 1 is 5. And -5 times -1 is also 5. But if you check these pairs for addition, 5 plus 1 is 6, and we need a 2. And -5 plus -1 is a -6, and we need a 2. So if this equation looked like this, you can't solve it using factoring. You have to apply a different technique. There are two additional techniques to solve quadratic equations, specifically to those that aren't factorable. They're called completing a square, which is what I'm going to show you today. And also there is a quadratic formula, and that's a separate video. So let's assume this is our problem here, x squared plus 2x plus 5 equals 0, and I will solve it using completing a square. One more thing before I start showing you the algorithm of solving by completing a square. When the original problem had a plus 1 here, we factored it. It ended up giving us two identical factors. The trinomials that factor into two identical factors, like this one, x squared plus 2x plus 1. When we factored it, we got x plus 1 and x plus 1. In other words, it was x plus 1 squared. So the trinomials that factor into two identical factors are called perfect square trinomial. So the idea behind solving equations by completing a square is to change the trinomial that you have into a perfect square trinomial. So this is our problem. We already checked. You can't factor the left side, which means we have to do something else, and today I will show you how to do it by completing a square. Completing a square requires you to perform a set of simple steps that will make this trinomial on the left side into a perfect square trinomial. So here we go. We're going to first divide every single term by the number that's next to x squared. The number next to x squared here is 1. So we technically have to say, let's divide all terms by 1, like this. Which we all know will change nothing, because division by 1 doesn't change anything. It's going to remain the same. This step is, however, very important to remember in case this isn't the 1. Like if it was a 2, you would have to divide all terms by 2. But it's not, it's a 1. So this step, we performed it, but it's just a technicality because nothing changes. So we still have x squared plus 2x plus 5. So that was step 1. Step 2 is to take the number that's next to x. In my case, it's a 2 plus 2 right here. We're going to take that number and we're going to divide it by 2. And it just happens to be a 2 divided by 2. This will not always be a 2, but you will always be dividing it by 2. So 2 divided by 2, which is 1. So again, we took the number next to x and we split it in half. We divided it by 2. We got a 1. And then we take that 1 and we square it, which is 1. These two steps will always be the same. You will always take the number next to x divided by 2 and you take that number and square it. We got a 1. So step 3 is to take the number that you obtained in step 2, which was a 1 right here, and add it to each side of the equal sign. Here's what's going to happen. We used to have this, x squared plus 2x plus 5 equals 0. This was our original problem. I will now take the positive 1 that I got here and add it on this side and on the right side. So at this point, here's what you see. X squared plus 2x plus 1 is a new trinomial, which is going to be a perfect square trinomial once you factor it. And then all this other stuff, that's this plus 5 and the 0 plus 1, which is 1, on the right side, they're all going to be condensed into one number. So let's first concentrate on this trinomial, x squared plus 2x plus 1. This is a perfect square trinomial. We actually just factored it in the beginning of this video. And that was x plus 1 squared. So this factors to x plus 1 squared. Now, this 0 plus 1 is 1. And I'm going to take the positive 5 and place it to the right side. And it's going to be a negative 5. So we now essentially have 1 minus 5. This is my new equation. X plus 1 squared equals negative 4. To solve this equation, you need to remove the square, remove the power of 2. And to remove the power of 2, we need to do the square root. So if you square root the power of 2 and the square root will cancel each other out, leaving you with x plus 1 only. On the right side, you also have to square root. And when you square root that, you have a positive and a negative. Well, every time you insert a square root into an equation, you have to make sure you place a positive and a negative in the front of it. And then square root of 4 is a 2. And the fact that the 4 is negative means the 2 will also have an I next to it. It's a complex root here. Well, here's another example. X squared minus 4x minus 6 equals 0. And now we'll be solving it using completing the square. Remember, first step is to divide by the number next to x squared, and we don't have that, so we will have a 1, but that, as we learned, doesn't change anything. So we're going to skip that step, and the second step is to take the number next to x, our number is negative 4, divided by 2, split it in half, which gives us negative 2, and we take that negative 2 and we square it, and that's a 4. What we do with that number, that's our step 3, is we add it to each side of the equal sign, and this is how I wrote it in the previous example. X squared minus 4x minus 6 equals 0. That's what we used to have. That's our original problem. Now I'm adding 4 here and 4 here. What we need is to factor this trinomial here. It needs to be a perfect square trinomial, that's the whole point. So x squared minus 4x plus 4, we need to find two numbers that multiply to a positive 4, but also add to a negative 4. Those numbers are negative 2 and negative 2. Negative 2 times negative 2 is a 4, and negative 2 times plus negative 2 is a negative 4. So this factors to x minus 2 times x minus 2, or x minus 2 squared. Then you still have this minus 6 equals 0 plus 4. Well, 0 plus 4 is 4, so you have minus 6 equals 4. And then you're going to take this negative 6 and place it to this side by making it positive. So 4 plus 6 is a 10. So this goes here and becomes a positive 6. You get x minus 2 squared equals 10. At this point, we are ready to square root each side with the purpose of removing the power of 2. To remove the power of 2, we need to square root each side. So I'm going to square root the left side and square root the right side. The square root and square cancel each other out. This is now x minus 2 without any other things attached to it. And then here you have a square root of 10. Well, you always try to simplify the square root of 10 or square root of anything. You always try to simplify the square root that you have here. Square root of 10 cannot be simplified. So all you do is put a plus and a minus in front of it. It's a positive 10, so there will be no I involved, but this is what you have to do, the plus and the minus in front of it. So now you have x minus 2 equals plus or minus radical 10, and all you need to do is get x by itself. To get x by itself, you add the 2 behind your square root of 10. So x is equal to plus or minus radical 10 plus 2. And here are your two answers. The first answer is positive radical 10 plus 2, and the second answer is negative radical 10 plus 2. So I also wanted to show you these two examples in the same lecture as completing the square. These problems here are actually fairly simple, and the reason being is because most of the work of completing the square is done for you here. All you have to do is to get the squared part by itself, square root, and then finally get the variable by itself as appropriate. So as you notice, you have x squared by itself here, and nothing else on the side of the equal sign, and then the negative 100 on the other side. So you're ready to square root, because square rooting will simply get rid of the square around the x, and you will have your x by itself, essentially. So you're going to square root the left side and square root the right side. On the left, the whole point was to get rid of the square, so you now have x. On the right side, you have a square root of 100. So first of all, square rooting, you have to put a plus and a minus in the front. Square root of 100 is a 10, so you put a 10 here. And then because 100 was negative, you have to give a 10 that I. And that's it. You got two answers, positive radical 10i and negative radical 10i. Your x is by itself at this point, so you're not required to add or subtract anything here. So for this one here, you also have a part that's squared. It's not by itself yet. You have a minus 36 on the same side as your u plus 6 squared. So you first need to move the 36 to the other side, and at that point you will be ready to square root each side. So I'm going to take the negative 36, place it here, make it positive 36. That gives you u plus 6 squared equals 36. 0 plus 36 is 36. So now u plus 6 squared is by itself, so we're going to go ahead and square root each side, like so. You get u plus 6, because square root and square cancel each other out, equals, since you square rooted, you introduce the square root, you have to put plus and minus. And then you say, what is the square root of 36? Well, that's a 6. It's a positive 36, so no I is required. Finally, to get u by itself, you need to move this positive 6 and place it here by making it negative 6. So u is going to equal to plus or minus 6, and then this 6 goes here and becomes negative, so minus 6. This 6 becomes a negative 6 on the other side. Because in this problem, when you square rooted the 36, it was an actual number. It wasn't anything with the radical. It was a nice number. You're going to be able to simplify this answer even more. So this is positive 6 minus 6. So remember, positive 6 minus 6 and negative 6 minus 6 are your answers. So positive 6 minus 6, that gives you 0. And then the second answer will be, as you can see here, I write it here at the top. The second answer will be negative 6 minus 6, which is negative 12. So these are your answers, a negative 12 and 0.